Okay, so we are going to continue our class here. We are looking at simplification of algebraic fraction. Okay, simplification of algebraic fraction. Okay, so this is what we are going to look at, and we have solved a problem that have numbers at the denominator. So here we are going to look at algebraic fractions that have algebraic expression at the denominator. For example, okay, for example, if you have 3 over x plus 1, okay, and you have 1 over x, okay, 5 over x minus 1, all these are algebraic expression or algebraic fraction with algebraic expression at the denominator. Okay, so this is the kind of fraction we are going to be looking at. Okay, this is the kind of fraction we are going to be looking at to see how we can be able to solve that. Okay, examples now. Example of simplify number 1 example, 3 over x plus 4 over x plus 1. Okay, 3 over x plus 4 over x plus 1. So how are we going to simplify that? The same way we have been solving our fraction, by finding the LCM of the denominator. So let me do the LCM here. So x plus 1. If you check in our previous videos, I told you that s plus 1, you cannot separate them, okay, because it's a complex number. They are not just, the s is not just alone, so there's nothing that can be able to divide these two, okay, because s plus 1 is together and s is alone. So if you divide by s, this one will give you 1, this will still give you back your s plus 1. Then if you divide by your s plus 1, this will not give you 1, this one. So the LCM here will give you x into s plus 1, okay, to s plus 1. So with that now, we can have our LCM of s and the s plus 1 will give you s into s plus 1. So s into s plus 1 divided by s will give you just this bracket, which is s plus 1. So that s plus 1 times 3, that will give you 3 into s plus 1. Plus this divided by this, the bracket will go. Of course, you can see you have that. So the bracket will go, you have x remaining. So the x times 4 will give you 4s. So what we have there, you now open this bracket, that will give you 3s3, okay, plus 4s all over s into s plus 1. This denominator is your choice to open the denominator, okay? Is your choice to open the denominator. If you like, you can open it. If you like, you can decide not to open it, okay? So when you simplify the numerator, the like terms, which is 3x plus 4s plus 3 all over s into s plus 1, okay? So that will give you 7x plus 3 over s into s plus 1. Okay, so we have simplified that. There's nothing else we can do there, so we have simplified that. So let's solve more examples. Number 2, let's have 3 over s into s plus 1 minus 4 over s into s plus 2. Okay, so you can see that here we have to find the LCM of this. Okay, LCM of this. So we are lucky to have something that is common, which is S, but unfortunately the brackets are not common. So if you use the method we use here to find this LCM, you are going to have S into S plus 1 into S plus 2 as your LCM. So when you use this whole thing here, when you divide this whole thing here by this, okay, this one and this one will go, this one and this one will go, you have only this left. So you're going to have 3 into S plus 2 minus, do the same thing here, these 2 will go with these 2, so you have this left, so 4 into S plus 1. Okay, so you open the bracket, this and this will give you 3S, this and this will give you plus 2 minus 4S, minus 4 times plus 1 will also give you minus 4, all over, you have S into S plus 1 into S plus 2. Okay, so that will give you this and this will give you minus X, and this will give you minus 2, all over S into S plus 1 into S plus 2. So whenever you have something like this, please make sure that your line covers everything. So that is the answer for our second example there. Okay, you can also have an algebraic fraction, that an algebraic expression is both at the numerator and at the denominator. Okay, you can have something like that. So it's still the same process that you will still have to carry out to solve your problem. Okay, so let's take another example. I think that should be our example 3. Okay, that should be our example 3. So let's say we have A plus 2 all over A minus 1 over 3AB. Okay, so we want to simplify this. It's the same process that we are still going to carry out. Our solution, you take LCM, okay, you take LCM of this. Remember I said that you should put this in brackets. Okay, so you take LCM of both the denominator. So LCM of A and 3AB, that will give you, there's something common which is A, so you divide by A, that will give you 1 3B. So you divide by 3B, that will give you 1 1. Okay, so you have your 3AB as your LCM. Okay, 3AB as your LCM. Then you divide 3AB divided by A, that will give you 3B. So 3B times this will give you 3B into, remember I told you to put this in brackets, A plus 2 minus 3AB divided by 3AB, that will give you 1. So 1 times 1 will just give you 1. So you open your bracket, so that will give you 3AB plus 6B minus 1 over 3AB. Okay, so that's the answer of that one. Let's go to another example 4. Assume that we have 3 over m minus n minus, okay, let's put plus m plus 3n into m minus n all square. Okay, so if we are to solve this, we have to take LCM, put everything in brackets to make things look simpler for us. M minus n plus m plus 3n all over m minus n square. Okay, so that will give, take LCM, go and solve the LCM. 3m minus n, m minus n square. So if you go with the first one, m minus n, this will give you 1. One of these will go with one of these, so you have m minus n remaining. Okay, m minus n remaining. So you go again by m minus n, that will give you 1 and 1. So that will give you m minus n into m minus n, that will give you m minus n square. Okay, so this is our LCM. So that's the LCM we are going to use here. So the LCM of this and this will give you m minus n square. In our last video, I said that in our videos, I said that if this is a factor of this, when we say factor, it means that it can be able to divide it without a remainder. So if this is a factor of this, that the LCM is the big. Like if I have 3 and 6, 3 is a factor of 6, the LCM is 6. Okay, so that's what we can apply here without doing all this. So this divided by this will give me another of this, because this we have it twice here. So that times this will give me 3 into m minus n, plus this divided by this will give us 1. So 1 times this will give me back my m plus 3n. So at this point I have to open my brackets. So this times this will give me 3m minus 3n plus m plus 3n all over m minus n square equals to this, and this will give us 3m plus m, I'm collecting like them now, minus 3n plus 3n all over m minus n square. So this and this are like terms, which is 4n minus 3n plus 3n. I think that will give you 0. Okay, it's just like when you have minus 1 plus 1, which will give you 0. So this and this will give us 0. So we have only 4m, then into m minus n square. So that is our answer. So I believe with all this now, you can be able to simplify algebraic expression, okay, that have algebraic expression. You can simplify algebraic fraction with algebraic expression at the denominator. Okay, there is more of those kind of problem which need to involve factorization. Okay, so we are going to move to factorization in our next video. Okay, we are moving to factorization in our next video, because we need some of the knowledge of factorization to continue with some of the problems which we are going to face in algebraic fraction. So see you in factorization of algebraic expression in our next video. Please do well to subscribe to our channel and share our videos and like our videos.